Lunchtime's over. Let's get back at it. Lunchtime for us. Facebook events. Stan Meyer's conference. Should be interesting for those who go. No idea what to expect. Fruit. Good. Okay. No. Let's see, I'm not even using channel 1. I'm not sure how that works either. Alright, I need to set this up. Finish setting this up. Okay, so 1 is my ground. Which is the same ground as this. Which is what I thought. I'm going to use this as my ground. Let's see, I'll just strip this down. Okay, my output it's all isolated, so my output is going to be, so this is going to be my input. This is going to be my output. I'm getting my pulse. 2 volts per division. Almost. There's my input. It should be directly tied to this. should be my voltage amplitude, but it doesn't change. That does, though. That's not what I want. Something ain't quite right with that one. See, diode 4. Diode 4. Connected to ground. Right. See, that don't make sense to me. That diode has to be in there to function, right? But it's not. I just need to look up this real quick. Verify. See, 1, 2, 3. So 3 is my okay, 3 is my on and off. My gate 2 goes to my output. That don't seem right. Hi, Element. Russ, I can't see the white paper in the way. You mean that? Does that look like a big blur to you guys? Probably. Oh, it's not lunchtime anymore. Something's fishy over here. I need to look this over. Can't read it. That's okay. Let me look at something anyway. Okay, you got isolated ground. This is all my outputs. Something's not functioning correctly. That goes through my load. That's what I did wrong. It's part of my problem. Let's take a 10K resistor. That's my input. And that should be my output. No, 3's ground. But see, that's not grounded. Yeah, it is. The output's the problem. Okay, so that should be a square wave, but since I have a resistor, it's an interesting way to set it up. It's a little different than I'm used to, I guess. Let's see, where's my second scope? That's the true output right there. too much. Yes, I am. Brought some fruit with me, though, to snack on. It's good stuff. Mangoes and blueberries. And watermelon. That's good. Why doesn't that make sense to me? Oh, because D1's... Okay. That makes more sense to me now. Oh, okay, that's why I have to have it that way. But I shouldn't have to connect the diode at all. And I should be able to measure. Oh, that's that. This is what I shouldn't have to do. There we go. That's without the diode. That's with the diode. So we'll hook the diode back up. I'm going to hook up my primary under a low voltage, not a high voltage. I'm going to hook up an amp meter so I can see how many amps I've got going. Let's just use this big old monster. Let's see, let me just remove this for now because you can't see it anyway. We'll hook up this monster. So our load goes. Why is that confusing to me? That is just confusing to me, the way that's laid out. I don't know why that's confusing to me, but it is. Okay, we got positive going in. The load has to go across these. It's so confusing to me for some reason. I need to draw it out differently. Oh, that's why. Positive through there, through here. That's all it is. It's confusing to me for some reason. Alright. So let's hook the scope up to the output. Directly across the output of the secondary. And get it on the screen. And we'll do 10 volts per division. Okay, if I turn frequency doubling already. Look at that. 2 low amplitude. Oh, let's get it bigger. Check that out. Okay. You're gonna get some matte glass cores to make it. I don't know. Probably not. I might. I think I have all the details I need to put that one together pretty easily. Let's see, I'm gonna put this meter over here out of the way. Still see it? Oh yeah. Okay, so I'm gonna limit my current. Which is going to limit my voltage. Let's see, I'm going to limit my current to about 200 milliamp. Which only allows me about 7.5 volts. Look at it ringing already. So what I want to do though, is that really ringing because of that, or is that picking up something else? Well, it really is. Wow. That's quite interesting already. I'm going to put this on a scale of times 10. And then I need to change it here. Now it's 100 volts per division. Put it back at 10. Turn this back up. Oh yeah. I'm going to limit my amperage to 150 milliamps, which only allows me 5.7 volts. Now my output, I don't know how much current I can pump through this little thing, and I don't want to burn it up. I don't want to melt the plastic on the coil. So what I am going to do, got it ringing on the primary there. What I am going to do is I want to measure the voltage peak to peak . Wow, look at that thing ringing. I'm only putting in 7.5K, which is what I wanted, and that thing's running at 22 kilohertz. Let's clear all these. Let's go to peak to peak, and I want to measure frequency. Okay, I want to go here, and I want to measure frequency, and I'm just my input signal, so I'm just gonna put actually I'm just gonna leave it for now. I'm not gonna do anything. I want to do a math function. I haven't played with the math functions much. But if I did math, and I did actually I just want to do haven't played with the math much. I'll play with that another time. Look at that though. 1, 2, that's exactly the right frequency changing. So now I'm going to change the frequency by 100 hertz. So there's 7.4, 7.2. Oh, it's not on that. Come on. Oh, I'm changing the wrong one. Keep forgetting I'm on the other channel. Turn that back on. Okay, going down in frequency. Hertz at a time. It's pretty close. Right there is my max. Wow, it's pretty high voltage. 660 volts out of that transformer with 5.7 volts in. That's pretty dang good. It's a, what did I have? It's a 6.8 to 1, I think. So if I do the math, if I take 5.7, multiply that by 6.8, that's only 38 volts. Now what happens if I connect the probe on the shielding of the wire, put it back on ×1, turn the scale way up, oh, and that's what it looks like on the shielding. Again, this is with not touching the wire. Oh, just dropped off. See, that's that exact amplitude. That's its frequency, which is about 8.8. Now if I increment this by 10, I'll show you what I'm doing. You can't see it though, but maybe I can make it bigger. Can you see that? There we go, there's even a bigger amplitude. Dude, I'd like to see some arcs off that sucker. Took the ground off. Let's see if we can still see that amplitude change. Let's go back down. So look, I'm going to arc these two together and see if we get anything. Nothing. Oh, you can't see that. But there's nothing there. Let's hook the times 10 back up. Now I'm at only 82 volts again. Here, let's change the frequency. The skin effect is different. Measuring from the surface. Now let's put 10 back in here. 100. Let's get our voltage way back up there and try to arc it. Now we'll increment by 10 till we find the maximum. Which is about there. $672 volts. Now let's see if it arcs. This should throw out an arc if there's anything there. Wonder what I'm actually measuring. Maybe we should put that 10k ohm resistor across there. We can measure the current. With some calculations, I can measure the current. Now we killed it. Turned it into a sawtooth. 14 volts with a 10k resistor across it. Should probably write these numbers down. Well, not yet, because I'm going to change the inductance right now. I'm going to do it without the resistor. Let's put it back on 10k. Check that out. So now I'm tuning the coil with, holy moly, with the changing the inductance. pretty sensitive, but you can tune it. You can get it right there. See, if I angle this, it's different, which is why I got these thumb screws on here, so I can tighten that down. So here's what I really want to do. I want to measure this at 0.04 Henry, and then I want to calculate. I want to actually watch the output. So let's turn this up. Let's see, hold on a second. Yeah. Okay, we're going to use 2 volts. Okay. So 2 volts is going to be our number. We're going to go with 75 kilohertz. Sorry, 7,500 hertz. Alright, so I'm running at 7.6, but I gotta go enter. There we go, 7.5. Alright, and then primary is going to be at 0.4 at my max amplitude. So let's just tune this thing to where it looks good. Let's just go all the way in. That is all the way in right there. We'll bring it out and see if we can get the amplitude high. This right there looks pretty good. Let's keep going, see if we can find another one. Nope, there comes another one. That was a little peak. I should probably way outside my field now, so I'm just gonna go back in until I get to that other peak. And I'm gonna take this apart and I'm gonna measure the inductance. Look right there. There. Now, for curiosity purposes, let's find out what inductance the primary is at. See, I'm going to use this meter and then I'm going to use my other meter. See if anything measures up to what I think. We'll start there. So that is measuring. I'll put it on low. Okay, that's measuring 183 millihenries, so 0.183 henries. Secondary should be around 1.6 for that frequency. Let's just see how far we're off. That's at 5.0. Now the way I calculated this probably makes sense why it's off. I'm not going to go into that right now, it's too confusing. Let's try it with this meter. Right at 100 millihenry at 100 hertz, 92 millihenry at 1 kilohertz, and 206 millihenry at 10 kilohertz. And we actually went back up. Let's try the other parameter. And this one is 2.8, 2.9, and 7, depending on the frequency. But hold on a second. Alrighty then. I really need to hook the whole circuit up to find out if this is true. So why not? Why don't we just hook the whole entire circuit up? What's it going to hurt? Not gonna hurt a thing. But I'm gonna tune everything first. So let's turn this pulse off. Let's try to match all the inductances correctly. Hey, we'll just see what happens. And I'm going to have to average these because I can't get these exactly right. Okay, L1 I have written down. This is at 75 megahertz, or 75 kilohertz, 7.5 kilohertz. L1 should be at around 1.87. It's at 1.8. I'm sorry, so it should be at 1.78. It's at 1.85. So what we're going to do is we're going to leave that one alone. We're going to try these. Okay, and this one is at 1.39. So I'm going to leave those. I'm going to write this down. These are calculated. These are actual. So we're going to say L2 is 1.39. 6. Just for curiosity purposes. It's measuring at about 508 hertz. Okay. That one was measuring at 508 hertz. This one's measuring at 506. So we're going to say this one's 1.86 Henry. So actually, if we wanted to make those closer, we'll just try it here. Just going to hook this sucker up and see what happens. Now we gotta do these. These are gonna be way out of whack. Tell you what, can you see my power supply numbers? Let me see. Oh no, I got the thing way out there. Never mind. Ooh, hiccups. Okay, secondary should be around 1.6. So I was way too close on my thing. Now I'm gonna leave it. We can try to match it. Actually, this one should be. Let's see, those are all slightly. Well, one's high and one's low. So we'll just set this one at 1.6. That's reading at 544 hertz. Man, I wonder if I can use that number to tune it. I'm going to try it. That's not what I'm going to do. I'm just going to try this for fun. I want to tune it with this. Tune it at what this is measuring at. So it's roughly 507 hertz like the other ones, and it's at 1.8 Henry. And this one's at 61 millihenry. So 0.061 henries. At a much higher frequency. 2,783. That's fine. That's the primary. I wonder if that will work this way. So what I'm doing is I'm using this cheap LCR meter, which shows you what frequency it's running at if you want to look at it by holding the function button. This is an LC200A cheapy, like $20–$30 meter, and it'll actually read capacitance right. So what I'm going to do is I'm going to try to tune everything at what this frequency is at, since these are really close to the values I have calculated for 7500 hertz, and just see what happens. So let me go find my diodes that I purchased a long time ago. A long time ago. You know the song. Bye bye, Miss American Pie. Drove my Chevy to the levee, but the levee was dry. Them good old boys drinking whiskey and rye, singing this'll be the day that I die. Here they are. U15.6. That's what I'm using. Okay. So these are U15.6. My cells are all connected. Not yet. No diode yet. I'm doing that now. Okay. Now the only thing I didn't do was measure or look at the secondary, which ones start and finish. That might not be important because they're on separate cores. Matter of fact, probably not important since they're on separate cores. So our primary through our switch, okay, yep, primary through our switch, alright, here's our current. It is important even if it's on different cores. But I want separate cores, so it just sees inductance. Right? Okay, so our L2, no, our L1 start. L1 start. This is this bad boy. Needs to go to cell positive, which is the inside. Now I'm going to hook my scope on the outside of the wire later just to visually see what's happening. I'm going to go ahead and solder this diode in the correct spot. So this diode is, I'm going to draw it on here because I'll end up forgetting which one's which. This diode is anode cathode correctly marked. like that. And then diode is going to go to the finish of C1. Stuff does not work well. This type of wire is so different. The coating on it is polyamide. I don't like scraping it because it takes the copper too, but I have to. Alright, so this is the cathode side. Pretty haggard, but hey, just gonna stay. Okay. Everything went blank. Let me check. Still going, still streaming. Maybe it's buffering. Can you still hear me? You just can't see? Alright, the anode goes to the beginning of the secondary. Okay. Just like that. Then we're going to go to the start. That's where my little magnet went. One of them. So the start. Like that. Move these wires up here. Then this is the finish, and it's going to go to the negative cell. Okay. So I'm going to connect my scope probe without the ground 1 times 1 to the outside of the positive. Okay. Put this back on times 1. I'm going to move this scope shot up here and make it a little bigger. Okay. These are my actual numbers. I'm going to write down that frequency, which is like 508 hertz. That's the meter. Was measuring at that. Okay. I'm going to turn my pulse frequency on, which I can put that back up here, even though you can't see it very well. Still put it up here. I guess it doesn't matter. I'm at 7,500 hertz. I'm going to hit start. There's my pulse. Turn up the voltage. I hear it humming. There's 3 volts. Let's go way in with this so we can see what's happening. Now these are not real measurements on the yellow. That's just a reference. It's my amplitude up to 5 volts. So just for fun, let's get an actual measurement on what the references are. So I'm going to go from the circuit ground, which should be the other side of the secondary, which is this one, to the cell positive, which is this one. There, let's get an actual measurement. There's what it looks like. We're at 13 volts. Now, you can see my frequency is doubling. No, it's not. Not quite. I'm going to change the frequency 10 hertz at a time. There we go. I want to get a better wave going here. There you go, that's a little better. That is frequency doubling. Right there. We're at 25 volts. And I went down in frequency. Just for fun. Let's do 100. So it's going to move 100 every time. I'll start back at 7,500. There we go. We're at 7,500. And I'm going to go down again. These are in 100 increments. I just want to see what I just want to see what happens as we go down. There's another resonant point. Somewhere in there, about 420, 410. 410 kilohertz. Let's keep going down. There's another point and another point. Kind of spreading out now. Alright. So we're all the way down to 100 hertz. So let's go up. And no, there's no gas coming out of here. So let's get back up to... There's no gating going on. I just purely want to see the frequency. So that's... .25 volts, frequency doubling at about 7 kilohertz. So let's keep going past and see if we get anything else happening. There's another resonant point, and it went away. 10 kilohertz. Now we're getting into a single sine wave. Oh, it just distorted over. Now we're climbing in voltage, look at that. We're at 42 volts across the cells. And going back down, I was right at about 20 kilohertz. Let's just keep going, see where it takes us. Okay, we're coming up on 30 kilohertz, and we're at a peak at about 40 volts. Let's keep going. Yeah, it's in between the C1 and secondary. Cathode facing the choke. Look there, it just died off completely. Got nothing. Outside of our boundaries there. That's overfill at 40 kilohertz. What, people? Working here. My wife. Okay, back to work. Alright, so I like the way the frequency doubling looked. Yeah, I'm just outside of my realm now. I'm just not getting nothing. Let's change it by 1,000 hertz. Keep going up. I just want to see if there's anything up here. Anything at all. It should be way out of the realm. Alright, so let's drop it back down to 75. Let's find that sweet spot. Actually, it was higher than that where we found that sweet spot. But I didn't have frequency doubling, so we don't want that. I want to go back to frequency doubling. and get the highest point. And then we'll crank up the voltage and see what happens once it. Okay, so let's go in increments of 10. Now this is without gating. Maybe I should turn gating on. Actually, I probably should turn gating on. I'm just going to leave it there. All my inductors are slightly high. The one choke is slightly low. So frequency should be lower. So that makes sense. Okay, let's turn gating on. Let me figure that out. Because I need to do master. Master. Let's put this at like 200. Start and see where we're at here. Okay, so there's what it looks like. Am I doing that right? Still need to mess around with this. And I'm not changing duty cycle. I need to play with duty cycle real quick. Let's turn that back off. Oh, I screwed it up. Let's go back and do it again. We're at 680. 680. Okay. Write this number down. Approximately 688. 6.88 kilohertz. Okay. So we'll play with that number for now. Fruit's good. Let's play with duty cycle. Okay, if I go down, it looks like that. If I go up, it looks like that. So the peak is right around 50% duty cycle. Let's try something else. All my measurements off. Let's just leave it there. I'm going to turn up the voltage. Put this at 10. And I could probably leave it at 1. Let's turn the voltage up. Let's just see what happens. I'm out of range already. I need to do times 10. Okay, so let's turn the current up too a little bit. I'm going to stick with 200 milliamps. It brings us to about 7.5 volts. We're getting 40 volts out. That's from our makeshift ground to our positive side of the cell. Let's see what just the secondary shows us. Okay, this is just the secondary. It's about 100 volts. To our ground. Okay, that's back up to our cell. Now I turned the voltage up. See what happens when we play with our frequency again. We can get a little more out of it. Look at there. A lot more out of it. Oh yeah, we're right at our 7500, which is what we were dedicated at. We're getting about 92 volts. Just keep going. There we're getting 100 volts. Only 200 milliamp. Still going up. Oh man. Look at that. Oh, peaked out. Peaked out at 200 volts peak to peak. It's pretty good. Let's play with our... Oh yeah, look at that. Ooh. That's our 2 cycle. Let me see if I can get that camera in focus a little better. It's going to change the frame rate, but it should be clearer. Ah, killed it. Oh, come on. Camera quit. Well, it died. I'm gonna stop this and start it again. See if we can get it back.